Welcome back to JavaScript Fundamentals 201. This is lesson 6, and we are going to pick up right where we left off in lesson 5. We had just talked about the prototype property that every function object has, and we also learned that every data type in JavaScript uses the prototype to define the methods for that data type. So the date object methods are all defined on date.prototype. The string objects methods are defined on string.prototype, and so on and so forth. So we're going to look at how we can use these methods that are predefined for us using some of our own values. So let's just jump right in. I've pre-written some code, but before we do anything with it, let's talk about what we are doing here. This is a functional programming approach to a calculator. This might seem a little weird, but this is actually some pretty good design. We have a calculate function which does nothing but facilitate the actual calculation. It doesn't perform the calculation, it just facilitates it. It accepts two numeric values, x and y, and then a function to execute, which actually performs the calculation. So the body is simply returning the result of calling the function that is supplied, and then passing x and y to that function. So we have two other functions that perform the actual calculations. We have sum, which is receiving x and y, and then it adds those two together and then returns it. And then we have diff, which once again is accepting x and y, but it is subtracting the two and then returning that result. So in order to make this code work, we call the calculate function. Then we pass two numeric values, in this case 1 and 2, and then the function that we want to execute. So this sum result equals calculate 1, 2, and sum. This is going to add 1 and 2 together and then return that result to sum result. So that's going to be 3. Diff result is going to call the calculate function, pass 1 and 2 for the numeric values, and then call the diff function. So this is going to subtract x and y, and it's going to return the value of -1. So if we run this code, we will see -1 inside of an alert box. There we go. Now, this is designed to be modular. This indeed looks a little weird because we have a calculate function which doesn't do anything except facilitate the actual calculation. Wouldn't it be quicker just to call the sum function? Yes, it is. But as far as our application is concerned, the calculate function is completely separated from the actual calculations. So we don't have to make any modifications to the calculate function in order to perform certain calculations. That's what these other functions are for. So if we need to modify how those numbers are added together, then we make that change in the sum function, or the diff function if we want to change how the numbers are subtracted from one another. And if we were going to turn this into a full-blown calculator application, the calculate function would need to perform some other code in order for the calculator to work. And that code needs to be separate from performing the actual calculation. So by breaking out the calculations into different functions and then supplying those functions to calculate, we've actually made our code pretty modular. So we can swap in different functions to basically do whatever we want. So if we wanted to perform multiplication, then we just write another function for that. The same for division or any other mathematical calculation. But there is a slight issue with this design. It's not very flexible because we can only work with two numeric values for each calculation. Well, what if we want to use 3 or 4? 10 or 20. That requires us to basically rewrite our code because yes, we could add multiple parameters to our parameter list. It's just as simple as adding individual letters. But we would also need to make those changes to our sum and diff functions. And even then, this isn't the best approach because what if we only needed 2? Because we need our code to be flexible regardless of how many numbers that we are working with. Well, this is where that arguments object comes into play. If you remember, every function has one of these arguments objects, and it gives us direct access to the actual arguments passed to the function. It doesn't take into account the parameters of that function, it gives us the arguments passed to it. So we can use the arguments object to make our code more flexible because our problem primarily has been a parameter issue. We can't have a flexible number of parameters, but we can have a flexible number of arguments that are passed to the calculate function. So let's modify our function to use the arguments object. And the first thing we need to do is get the function object that is passed to the calculate function. As it is right now, the final argument is the function object. So we can use an array method to get the final elements within an array, because remember, the arguments object is an array-like object, but we are going to hit a wall here in a second. But let's first write this code. We'll create a variable called fn, and in fact, let's go ahead and get rid of these parameters because we don't need them anymore. So we want to get the final element within this array. So we can do arguments dot pop. And then that is supposed to return the final argument in the array. But there's a slight little problem. The arguments object is not an array. So if we try to execute the pop method, we are going to get an error because the arguments object does not have a pop method. But the pop method is specified on array.prototype. So let me type that out. Array.prototype.pop. And we can use some methods of function objects in order to call the pop method as if it were running on the arguments object. In order to talk about the function objects methods, I'm going to duplicate our tab in Chrome so that we don't mess up our existing code, so that we can just talk about the function object first and then apply what we learn here into our calculating code, which we will come back to in a few minutes. Okay, so we have three objects. One's called obj, one's called foo, and one is called bar. This first object has a name property. Obj object is its value, and then it has a do something method. Then we have a foo object. It only has a name property, and that value is foo object. And very similar to that is the bar object. One name property, and then a value of bar object. So foo and bar do not have a do something method, but we can actually execute the do something method as if it were attached to foo or bar. So let's look at how we would do that. First, let's call do something as if it were just any other method. So whenever we run this code, we will see an alert box that says obj object. So I'll click run, and there we go, obj object. Well, this do something method is a function object. Therefore, we have two methods that we can use to call this do something function as if it were attached to the foo or the bar objects. The first of these methods is called apply. And there are a maximum of two arguments that we can pass to this apply method. The second one is optional, but the first one we do have to specify, and that is the object in which we want to call this function object in or within the context of. So we have do something, we want to execute it as if it were attached to this foo object. So we just simply pass in foo. So whenever we run this code again, instead of seeing obj object, we are going to see foo object. And even though we are calling do something by obj.doSomething, this apply method is modifying how do something is executed. It's being executed as if it were a part of this foo object. We can do the same with bar. Let's run it, and we will see the bar object displayed within our alert box. Now the second parameter is optional, but it is an array of arguments that we would pass to this do something function. Right now, there's no arguments being accepted, or at least no arguments being passed, and we're not doing anything with arguments inside of do something. But let's make this just a little bit interesting, and let's pass in two values, x and y. And let's concatenate these values to our string. So let's do a space, followed by x, followed by another space, and then y. So if we were to call do something normally and pass in 1 and 2, then we will see object and then a space, and then 1 space, and then 2. And there we go, object, 1 and 2. But if we wanted to call this as if it were part of the foo object, we would use the apply method, pass foo, and then pass an array of the values that we would pass to this do something method. So if we wanted to pass the same values of 1 and 2, we would do so inside of an array. And whenever we run this code, we will see foo object 1 and 2. And the same for bar. But let's change these values to 4 and 5. So whenever we run this again, we will see bar object and then 4 and 5. So that is the apply method. There's another method that is called call. And it is very similar. In fact, it does the same thing, but the arguments that we pass to call are a little bit different than the apply method. The first argument is going to be the same. The object that we want to call the do something function as if it were a member of that object. So we will see bar object displayed, but we are seeing undefined and undefined because x and y were used within the do something function, but no values were passed for those arguments. So the call method, instead of specifying an array of values for those arguments, we just simply type in the argument list. So we would do 4 and 5. So whenever we run this again, we will see bar object 4 and 5. So it's positional. The second argument that you pass to call is going to be the first argument that is passed to whatever function. In this case, it's going to be do something. And the third argument is going to be the second argument within that function, and so on and so forth. So if we wanted to do the foo object, we could do that as well. Let's change this to 15 and 20. And we will see foo object space 15 space 20. So now that we know how to call a function as if it were attached to another object, let's go back to our original code and let's use array.prototype.pop, and then we will call either the call method or the apply method. So let's get rid of this and replace it here, because we want to assign this array element to the fn variable. So we can use the call or we can use the apply. It doesn't matter, because all we are going to do is pass in the arguments object. So we're saying we want to call array.prototype.pop as if it were a member of the arguments object. So this is going to give us the function object and assign it to the fn variable. It will also remove that function object from the arguments object, because the array's pop method takes the final element within the array, removes it from the array, and assigns it to whatever called the pop method. In this case, that is the fn variable. So we end up with an arguments object that no longer has the function object, it just has all of the numeric values. And that's really perfect, because then we can just pass the arguments object to the function without having to worry about performing our calculations and then trying to perform a calculation with a function value. So this is going to work out really well. But whenever we call fn, we do need to change our syntax, primarily because we no longer have x and y. All of our argument values are stored within this arguments object. But likewise, we just can't pass arguments to our function because the sum and the diff functions expect the arguments to be passed individually. They are not expecting an object that contains all of the values or an array of all of the values. But if you remember, we talked about the apply method and its second parameter, which is an array of all of the values that we want to pass as arguments to the function. So the first argument that we are going to pass to apply is going to be null, because we don't want to execute this function as if it were a member of another object. Now, if we had a full-blown calculator application and if we had a calculator object, it might make sense to specify the calculator object here, but we don't have that, so we are just going to specify null. And the second argument that we are going to pass to apply is going to be the arguments object. Now, once again, this is not an actual array, but it is an array-like object. So the values contained within the arguments object are going to be individually passed to the sum or the diff functions. So without making any changes to sum or diff, let's test this code and see if we get the same results as we got before. So let's run. And we get -1 because we are alerting only diff result. Let's also alert sum result. So let's copy and paste. Sum result. Let's get rid of that white space. Let's run again, so we will see the value of 3 and then the value of -1. So as it is right now, our calculate function is working perfectly, and we can pass as many arguments to calculate that we want. Now our limitation is with the sum and diff functions, because they are only working with 2 values. So to make these more flexible, we will once again use the arguments object, but in the case of sum, all we have to do is keep a running total, because we are just adding all of the arguments together. So let's first create a variable called total. We will initialize it with a value of 0. And then we are going to use a loop. We will loop over the arguments object, adding each element to our total. So let's start with 4. Var I equals 0. This is our counter. Let's also create a variable called L for the length of arguments. So arguments.length. As long as I is less than L, this loop is going to execute. And then we want to increment our counter, so I equals I plus 1. Inside of this loop, we want to simply say total equals total plus arguments I. So it's going to add each element to total and then give a new value to total. So at the end, all we have to do is return total. So let's modify our call to calculate for our sum. Let's do 3, 4, and 5. This should give us a value of 15. So whenever we run this code, we should first see 15. And then, yes, hooray, and then we see -1. Okay, so now we need to modify the diff function, and this is going to be just a little bit different because we are subtracting. If we copied and pasted this code, which I will go ahead and do, and if we just change the sign from plus to negative, we are going to have a slight little bug because it's not going to subtract 1 from or it's not going to subtract 2 from 1, it's going to start subtracting 1 from 0 first, and that's going to give us -1, and then it's going to subtract 2 from that, which is going to give us -3. So just to show you, we got 15 and -3. Well, this is actually really easy to fix because we're starting our total at 0. Instead, we need to start our total at the first value that was passed to the function. In this case, it's going to be arguments at index 0. So we start total off with, in this case, the value of 1. Then we need to modify our loop to start counting at 1. Because we already have the first value of arguments assigned to total, we need to start counting at 1 so that we start the index at 1 inside of our loop. Now this is one way to do it. We can actually write this using the same type of logic, but without modifying our loop so that we start counting at 0. And we use a method of the array data type. So array.prototype, and this method that we are going to use is called shift. This is going to get the first element of the array, remove it, and then return that element or that value to the total variable. And we are going to either use apply or call. It doesn't matter because all we need to do is call the shift method as if it were a part of the arguments object. We don't need to specify any arguments to pass to shift. All we need to do is specify the arguments object. So this is going to call shift on arguments. It's going to remove the first element within the array, assign that value to total, and we have a new array, or a modified array rather, that has a different length. So if we were to run this code again, let's get rid of x and y as parameters. If we run this code again, we will see the values of 15 and then -1. So let's make this like we did with the sum. We are doing 1, 2, 3, 4, 5. So this is going to give us -1, -4, -8, and -13. So if we run this, we get 15 and then -13. And that's it. That's all we are going to talk about today. Today you learned how you can call a function as if it were a method of another object. And this is very important whenever you get into object-oriented JavaScript. But since we're not doing that, and that's it. That's all we're going to do today. Today you learned that you can execute a function as if it were a method of another object. And that's something very important for whenever you get into object-oriented JavaScript. But even then, we've seen how useful it is outside of that context. We were able to use the arguments object as if it were an array by simply specifying array.prototype and then whatever method, and then followed by the apply or the call methods. So you can use this in your code. In fact, if you look at some people's code that use the arguments object, you will more than likely see this technique used, because this is how we can make the arguments object act like an array. So with that, have a good one. I will see you in lesson 7. Take care.